Yeah. Well, we restructured the business. Yeah. No, that's still was by using language yeah. You might actually know that word for that,
This is the start of the OpenID London workshop. We'll be starting in a few minutes.
Low-level special effects.
Yes.
The hub knows which service you are going to, but basically you should right, okay. So quality doesn't matter. There is and this is the how. And whether there is a chain. Now, I don't sit down across those lines down. Yeah, but I think we have problems. And the suggestion of potential for another child, that's actually should. So, explain issues because just kind of I think it's challenging was government is always taking support items and think out there. Yes, our relationship with government. Yeah. And if something goes wrong, my customers and I try to say, well, yeah. I'm not watching them. This is one of my but people don't yet understand the ocean and the areas important to well, this will be yeah, no, definitely, yes. But there is well, I'm expecting to be able to provide it's something I'm not expecting that these students solve transactions. I'm not expecting to solve in the same way that school guys call you up and say someone is right. Well, so wait a minute, how was it that one stuff into the field and I would just that's the question. And I don't know where it goes. And so I'm not so we never find it. So that has plans nothing from why don't they know how much it's well, how does it sound this the assumption that's challenging. But there is the scheme what people understand from the system. But actually, if that is all they do, then I should want to identify it as the rules actually change. I think we're saying we haven't yet. But we have pressure to ensure that they're right. And I appreciate that. At the same time, it's just not and so the challenge then is how you get a rule back on you can use the state and and so if you have the rules, well, that's kind of fun. Yes, like I can see why you need to do this, like service. I want to get my wow. So we do this. This is the other. This is the other problem that you think that's up.
Yes. So I've got a Google Hangout going right now, which is video conferencing. Okay, but you can watch it okay, right? This computer is set up to be doing screen presentations to Hangouts. Okay, right? And so if you use your slides here, my presentation go through them, that it's both going to be synchronized with Hangouts. Right. Okay. And then I have I've uploaded my That solid. I'd like to use that local network.
I think I've got to do 2 minutes on software. Help on the safety file. Oh, okay. So
Do you happen to know if there's
yeah, it should do.
So I think I will keep that in the back because it looks like that. Yeah. Great. Okay. Perfect. Do you need to project in to do the safety announcement, or can you do that with okay. Run
Seem to be doing the right thing.
So why don't you do a visual intro and then I'm going to explain what we're going to attempt to do. So why don't you start and then I'll start with Joe. Have we already called people in?
Yes.
We have being called in. Just talk about
Good morning. If we could gather around the river. Good morning, everyone. I wanted to get started first with a word from our sponsor and host, Microsoft, and Phil. Thank you. Thank you, Don, and welcome to London to the OpenID workshop. My name is Phil Spading of Microsoft, and as some of you will be aware, over the last couple of weeks we did a joint effort across Google and the everlasting Don to host the workshop here. I've just got to do some health and safety on fire. This is my duty, and I'll be speaking later. So now that you're all in, the emergency exit, if we need them, if we hear the alarm and we hear this message come over the tower, the emergency exit is back towards where you came in, and a team of yellow jacketed people will show you where to go. I will be running, so please follow me and try to keep up. You will exit out of the building and gather by Marks and Spencer's, and that is our gathering point. In terms of a couple of other logistics, for wireless access, details are on the board over here to my left, and the restrooms are also over to my left, out the door, but they are gated. So you either ask one of the hostess teams to help you, or there is a code on the bottom of the board to let yourself back in. Those are the logistics. Thank you very much. We're going to switch out to another set of computers as this meetings here are being recorded and also being broadcast as part of a Google Hangout to our colleagues back in the States and elsewhere. My name is Don Thibault. I'm here representing two organizations. One is, of course, is the OpenID Foundation. The other is the Open Identity Exchange. We'll talk more about that. But the OpenID Foundation has been hosting these kinds of meetings, meetings that talk about identity from a technology protocol level and also in policy and business model level as well. This is part of an ongoing series of these kinds of workshops. I guess the last one was in Tokyo, where we had over 300 people join us and spend the better part of the day
poking at these issues of internet identity from a technology, business, and policy point of view. So what we wanted to accomplish today was to give you an opportunity for a deep dive into the evolution of standards, open standards in this space. And as part of this welcome, I also wanted to give you a warning. And the warning is that, as most of you know, the terminology and the terms of reference in this space are rapidly evolving. Over the last couple of days, both conversations at Whitehall, Cabinet Office, and then yesterday with the service provider and vendor community, it became very clear that the rubric around identity provisioning online is a challenge for all of us. The notion of an identity provider is evolving, as you'll hear today. So that's the warning about trying to have communication across multiple points of view on the moving target that is online identity verification and authentication. So that's the welcome, that's the warning, and lastly is kind of our working hypothesis. And perhaps it's not overreaching to say that this is a particularly important conversation to have at a particularly important time in a particularly important place. And what I mean by that is that here in the UK, people like Stephen and Cabinet Office colleagues, people in the DWP are about to embark on a fairly sizable adventure in moving a very large percentage of the UK population to an online identity verification alternative to the receipt of benefits here in the UK. So it was with mixed emotions that I was received when I said the whole world is watching, because we have, certainly in the UK, maybe a forcing function for many of the issues that we're talking about today. We certainly have in the US, as you'll hear from Kik in the Netherlands, as Matt can describe in Asia Pacific, multiple experiments at a national level where governments are trying to find a solution to the provisioning of services at a time of decreasing budgets. And of course, one answer to that, the primary answer to that, is to engage citizens online. And the challenge that, as we all know, is you have to verify who they are and elevate that trust in order to provide those services. The primary topic today, though, is not necessarily the government use case, but rather a review of the status of the protocols, the evolution and changes of those standards, and the impact that they have on the business case. So my colleague Kik, if you join me, and I would like to try and provide some context and some framing for where we stand today in this journey. By way of introduction, many of the members of the board of directors of the OpenID Foundation are here with us, and I wanted to point them out, at least on the screen, and not embarrass them personally by suggesting that the OpenID Foundation board is really a meeting point. I described it yesterday as a team of rivals, so that you can have the opportunity of hearing from leaders in the industry, like Patrick Harding from Ping Identity, Eric Sachs from Google, and Andrew Nash from Google, and then our colleagues and hosts from Microsoft. Tony Navlin represents Microsoft on the board, and Mike Jones happens to be from Microsoft and is part of the leadership team for the OpenID Connect working group. So buttonholing these individuals and asking more detailed questions about the work that they're doing is something that hopefully will be beneficial in both directions. The other thing that I'm always obliged to do is talk about membership in the OpenID Foundation. That membership is available to you as individuals, but also to the organizations that you belong to. And the OpenID Foundation, as you may know, is a nonprofit standards development organization that really is, again, a meeting ground for a number of companies with very divergent and often competitive interests that see the need for interoperability at a technical standards level and see the need for these kinds of conversations that you'll take part of today. One of the things that is an important priority for the board of directors of the OpenID Foundation is to do a better job of taking that conversation from Silicon Valley to, as I suggested last December in Tokyo, to here in London today, in about a month's time in Munich. So this conversation really requires local input and feedback, particularly when we talk about something as fundamental as we believe that OpenID Connect will be to identity solutions on the internet. The other thing that we wanted to accomplish today was not only give you a sense of the status of the evolution of the OpenID protocol, but also talk about its next step, which you'll hear in detail about in terms of OpenID Connect. While OpenID Connect, I believe, is a really fundamental piece of plumbing for the solution set of online identity, you'll also hear today about another protocol that's in the OpenID Foundation pipeline called Account User. And while OpenID Connect is a fundamental piece of plumbing, Account User is very sexy. So you'll have a chance to get a sense of technology that originated at Google and that will be available, we hope, we anticipate, through the OpenID Foundation as an open standard available for experimentation today and adoption soon. So we wanted to spend the day giving you this deep dive into the state of the art and the protocols of internet identity. This afternoon we'll talk in more detail contextually in 2 breakout sessions about both the technology but also the other layer that's important for a solution set. We think about OpenID Connect User as protocol level solution sets like the challenges that the government of the UK is taking on here, the NSTIC in the US, and other similar efforts in other countries and regions of the world. The policy level is an important part of that. At policy level, we've been using a wrapper called the Trust Framework. So we'll have an opportunity to hear about the tools and the rules and give you a chance, I think, which is a very unique one at a very important time, to hear the perspectives, the areas of commonality in this team of rivals with some leaders, again, from Microsoft, Google, King Identity, and other companies that are part of the OpenID Foundation. Companies big and small, companies that have different roles to play in the ecosystem, like ABF, our colleagues, as well as the larger implementers that I mentioned earlier. Speaking of colleagues in other places of experimentation, Kik has really been our point man for the foundation in the EU and has been sensitizing not only the board but also the broader community about other identity experiments taking place in the government context, live and soon to be discovered in the Netherlands and in other EU countries. So what we thought we'd do is that Kik and I would co-present a bit of the context for what you'll be hearing in terms of trust frameworks and the protocols themselves. Yeah. Kik, why don't you introduce yourself a bit and talk some more.
Yeah, so thank you, Don. First of all, I would like to thank the foundation being here in Europe. As a European board member, of course, I really enjoy the fact that we are now having this workshop in London. Personally, I'm now involved for 2 years in the OpenID Foundation.
You can stand there. You'll be videoed for people online watching.
So you can hear me. So my background is a business background. So what I think and what I think is very important also as a community representative is discussing a little bit about the why of OpenID. So I'm involved in several projects in the Netherlands, advising retailers, insurance companies, and government on identity. And well, most of the time they don't really care because they say when you talk to the business people and the marketing people, they have a lot of projects on their list, and they see double-digit growth of e-commerce, and most of the time they have a password management system in place, or they don't even care about who it is. They just want to sell products and deliver them. And business budgets, most of the time, they go to marketing, creating Facebook apps, or giving away free things to have more likes. And they don't, well, they experience the problem of the key necklace every day themselves, but they don't see it as their business problem, because it's the problem of their customers, and well, they enjoy, and maybe from a well-willing perspective, they want to contribute to solve it, but they don't really see it as a business problem, and therefore it doesn't come up to the projects they work on. But on the other hand, you see things are changing, because there's a few use cases and developments that make it interesting for the business decision makers to learn about identity. And I want to present a few of those, and also to give a little background why it is important for business decision makers to learn more about OpenID and the rules and tools they offer. So from the experience I have the projects, of course everybody wants a mobile app nowadays. We even see at certain service providers that the break-even point is of web traffic and mobile traffic is there, and all their consumers are on mobile devices, but they face a problem there. Because the question they have is, how do we recognize our customers currently on the web, also on other channels? And how do we provide them a compelling user experience? Because I see a lot of examples where when you go to the mobile website of a retailer in the Netherlands at least, they ask you to go to the website first and register before you can do some mobile shopping. And I don't think that is very good for your business. On the other hand, everybody wants to be in social media because they want to engage with their customers, they want to listen to their customers, they have web care in place, and they want to know how to integrate with those new channels. So how can we communicate to our customers via Twitter, via Facebook, or Google+. The problem is, how do we also recognize they're our customers? Because maybe you experience it yourself, but if you complain about a certain service on Twitter, people may contact you and ask you to send an email with your customer details so they can contact you and really know who you are. And I think it's not very compelling if you do it like that, but you already want to know who that customer is in the first place. So that's also a question for the marketeer. Another development is cloud services. Also marketing people want to implement cloud services so they don't have to talk to their IT department anymore, because it takes a lot of time and they need to make big plans to implement, and they need to claim resources. So cloud is a very interesting development for them. And so they start integrating third-party services to their own portal. But the problem there is that a well, they offer it to their employees or to their customers, but the problem is, how do you offer a seamless login for this portal? Because if the user has to log into the Cloud Service 1, Cloud Service 2, Cloud Service 3, and also your own portal, then it's not a very interesting use case for your customer or employees. An additional item which is on their agenda is open data, but it's fully open or at least personalized data. Product managers at the moment understand that if they want to have more innovation in their products, they need to open up their data, because there's other app vendors or innovative companies that can do much better creating applications with their data instead of their own innovation department. The same is happening for portals. So the marketers understand that they don't only need application on their own portal, but they need to go to where their customers are daily. Yeah? So customers are daily on their LinkedIn or on their Google or on the entrepreneur page or on their daily shopping page. So they want to have their application on those sites. The challenge again, how do we provide personalized widgets, or how do we provide this personalized data to the app vendors and make sure that it's really that customer, or at least how can the customer delegate his rights to the application to show his personal data. On the other hand, the key necklace is becoming a problem for them. So whether it first was a problem for the consumer himself, it now is a problem for businesses, because we all see a lot of hacking at the moment where reuse of passwords is used on other sites. So they need to protect their consumers in a stronger sense, and therefore they look, okay, how can we implement multi-factor authentication, and how can we lower the password risk? So that's also on their list and the question. So now maybe it is possible to create a positive business case for identity, because normally this is how they make a business case. They have three topics. They want to increase revenues, they want to lower costs, and they want to comply or at least decrease company risks. And when you look at increased revenues, when you want to attract new customers, I think the OpenID and the Open Identity developments are a good way to attract new customers, because you probably already know new customers when they come in, and you don't have to register them again. You can also sell new products on new channels, because if the identity supports mobile, television, social networks, you are able to provide your services on those channels. So you can also quantify this business case, because, for example, with the insurance company who made this business case, you can have figures like they have 14% loss of conversion because of email verification. And if you already know the email of your consumer and you don't have to do email verification anymore, that will help you with 14% more conversion. And I tell you, the marketing people really like that figure. So in the end, I think this is a business case that marketers need to make to bring together the pieces of identity at this moment of time. And this is really the why RPs should implement technologies like OpenID. And I'm not going to do that, because I think that is what we're trying to do at the moment.
Indeed. So I was wondering if there was any questions that people had at this point, or one of the things that we want to be able to do today is to talk about use cases that that are appealing to RPs from a different point of view. I know I'm going to hear from Eric Sachs about replacing passwords, and again, just to review what we'll be talking about today, OpenID Connect, Chooser, and identity verification and authentication alternatives. Also, just a quick review, you'll hear from the OpenID Connect team status report on where they stand in terms of integrating OAuth to OpenID Connect and the path forward. And I think that is the context setting that we wanted to do. Eric,
I'm just going to switch over to their slides and see if there are questions for you guys, and then we'll see if we can get those guys up. But any questions for?
We'll take questions while the next team, I think, is our colleagues from Microsoft.
So Mike, John, and Nat, whoever from y'all's group will present. That's your slide. Just right over on the left there. Can you switch this to
Yeah, sure.
That's the slide you sent down.
Okay, I'll use those.
Go.
No, actually, there's a
You
whole...
want to switch, you can switch.
Okay, that would be better.
Send me the slides later and I'll hook it up.
There's a whole bunch of stuff you don't want to see in that deck. The deck that I sent yesterday was one that I presented to the IETF on the standards work in OpenID Connect and how it relates to some of the detailed technical standards that we're depending upon in the IETF. And while all of that is in, we'll postpone for now. And while all of that is underpinnings, I think you're more interested in the business presentation than the mostly bits and bytes presentation. So I'm Mike Jones. I'm an identity standards architect at Microsoft. I work closely with the OpenID Connect working group and other leaders in the industry to help build this identity platform that I'll be overviewing for you a little bit this morning. So as Don was saying, this is an incredibly collaborative effort. While my particular company may be a fierce competitor to my friends at Google and certain businesses and a fierce competitor at Salesforce in others, we share a common interest in having our customers have a great identity experience and enabling all of our customers to make their businesses work better. And so we're all collaborating to do this thing together, which we think it is going to be greater than any of us would be able to accomplish individually. This slide is almost redundant given what Nat or what Don and Kik had already said. This is a very international group. We have many different continents represented, and this is by no means exhaustive, just to give you a sense of the broad participation. So what is OpenID Connect? OpenID Connect is a very simple identity layer built on top of the already successful OAuth 2.0 protocols. What does it do? It enables clients to verify the identity of the people, the users, using their systems. It enables clients to obtain basic information about those users, simple things that most websites or applications want, like name, address, potentially email, maybe even verified email to give that 14% back that Kik was just talking about. And this is not the first OpenID protocol. There was a previous OpenID protocol which was successful in some spheres, but it wasn't designed for the mobile phone, and it wasn't built on the sort of modern JSON and REST interfaces that most developers are wanting. So this is an attempt to both broaden its reach and to build something simpler.
I got easy. Much longer.
I think I have competition. We'll just continue. We can all listen in on John's call. This is a privacy exercise. So the range of what we're trying to accomplish is fairly broad. Everything from simple social networking use cases where things are fairly low value and easy to do, to enterprise and cloud use cases, to mobile use cases. We span privacy and security requirements from things mostly being out in the open to things being encrypted and very targeted between the parties that you are communicating with. And we span what we'll call sophistication of claims usage from a lot of websites or applications that are willing to just take whatever the default is and run with it, to others that are in particular business cases that need very specific information, potentially fulfilling requirements of a particular profile and a particular trust framework. And we do this all trying to keep things as simple as possible by reusing OAuth and some lower layer pieces that are all pretty simple to do. How is this different than the previous version of OpenID? For one thing, as we just talked about, it supports mobile applications and rich client applications on PCs and Macs and what have you, not just websites. OpenID 2.0, the old version, required people to use identifiers for themselves that were URLs. Now, I don't know about you, but most people don't think of themselves as a URL. Most people may have trouble just remembering their email address. And so letting them use the email address, which they might remember, is a heck of a lot easier than expecting people to be URLs. We do provide this standard set of information that I'll talk about, 80% use cases. It's designed well to work on the mobile phones. We use the modern REST and JSON protocols. Unlike OpenID 2.0, which didn't support any encryption at all, you do have the option of encrypting the claims data, which for a number of government and commerce use cases is pretty critical. And then we have support for something that's new, which I'll talk about in more detail, which is aggregated and distributed claims. And what that is, Don alluded to the fact that this thing called an identity provider, and even the terminology is evolving. You might want to be able to get authoritative information from multiple places, gather it together into a bundle, and deliver that bundle, and still have the receiver know authoritatively where the places were and whether they can make trust decisions based on it. All of that's new in OpenID Connect. So that's my introduction. For the remainder of the time, I'll look a little bit about the design of Connect. We'll look under the covers a little bit about how it works. I'll give you an overview of the specs. I'll look at how we got here, the timeline, and what comes next. I'll talk about the role of developer feedback in evolving and tuning the specs to make sure that they're the right thing. We'll talk about next steps, and I'll close by giving you some resources. So philosophy matters in engineering, actually. If you don't know what you're trying to achieve, it's pretty sure that you're not going to hit it. We decided up front to keep simple things simple in the whole design, but at the same time recognize that not everything can be simple, and to make complex things possible. But go back to point one, which is even though the complex things are possible, that can't make the simple things not simple. And so when, we're deep in engineering discussions about what do we do, we always try to return to point one for adoption reasons and make sure that people can build the simple things. So for instance, one of the simple things is providing a standard set of identity claims in the normal case for the 80%, and making it designed to work well on mobile phones from the get-go. We make it simple, as I've said, by building on existing industry standards. The goal is to make this easy to build on all modern web development platforms without needing extensive libraries. I compare this to some of the work, even in OpenID 2.0, where you were required to have an XML parser, an XML canonicalization, all these things that, we thought at one point would be ubiquitous, but it turns out that at least the web community thought, oh, those are hard, we'll do something else. So an example of the complex things that we do make possible, because there's business need for them, are the aggregated, distributed, and encrypted claims. And I'll show you a diagram now of what I mean by that. So aggregated claims is this notion of having one set of claims from one authoritative source, maybe commerce information from PayPal, and other claims from another authoritative source, maybe from the UK Post about your postal address. And aggregating those things together and delivering them as a package for the relying party, so that even though different parties are authoritative for different information, you can gather it together as a whole and use it. So in that case, the identity provider becomes a claims aggregator and delivers signed claim values to the relying party. So distributed claims are just like that. Here, watch the arrows move. Except, boy, I get to the UK and they must not like my security profile at all. Distributed claims are just like that, but for those of you who took computer science classes, they are passed by reference rather than passed by value. So rather than the identity provider bundling them up, they just remember where you can go get them. They tell the relying party, oh, you can go to these places and get the authoritative claims. So this is a work in progress, but one that's well along. Part of the data for that that we engineers and protocol designers are using to gauge how far along we are is interop work. We're currently in the midst of active interoperation between multiple implementations. There's currently 8 implementations online, publicly available. You could go to them right now and use their Connect endpoints. There's 56 different individual features that we're currently testing. So, can you support an ID token? Can you support profile claims? Can you support this and that and the other? Trying to do feature coverage of the specifications. There's 507 tests recorded, at least as of a couple days ago. There's 57 people participating in the interop work on the mailing list. And people have said 239 things to each other. One of the things that the engineering team behind Connect is doing this week, partly while we're back down in Paris at the IETF meetings for the rest of the week, is mining this data to figure out which parts of the specs have been tested and which parts still haven't been. And that gives us a sense of what more interop work we have to do to be able to have high confidence that this all works really well and people are building it in an interoperable fashion. So how does this work? I'll just breeze by this quickly. There's this notion of an ID token. It represents a set of claims about your logged in session. So what's in an ID token? Well, who issued it? So who's saying you're logged in or that you're authoritative? Who are you? The user ID of that issuer. Who is this intended for? So, you know, Don might be the issuer, and he might be saying, I'm Mike, and Mike has this role at the foundation. You guys, in this case, would be the audience that this message is intended for you. There's usually an expiration time on one of these that maybe this message is going to time out after the end of the day. And then there's this technical thing called announce to prevent replay text. So that ends up being represented in a JSON structure like this, where there's a name-value pair for each of these claims. For those of you familiar with SAML tokens, this is just like that, except that you change the angle brackets to curly braces, and the signing is a little bit simpler to do, but semantically, we're in the same place. One of the ways that we made Connect simple in the 8% case is the ability to request standard sets of claims with OAuth scopes, rather than having to enumerate every single claim every time. So you always use this scope called OpenID to say that it's a Connect request. There's a set of profile claims, such as my name, things like my time zone, my language. You can request email address and whether it's verified. You can request a postal address, and you can request a phone number, all without listing every claim in gore detail. On the other hand, making the complex things that are sometimes necessary possible, you can use this general purpose request object to request an arbitrary set of claims and say whether they're optional or not. Again, like a WS Trust claims request or a SAML claims request. This is the standard set of claims. This will not work for all use cases, but it will work for, again, the 80% use cases where an application or a site wants to establish a quick relationship with the user without bothering to say, please tell me all these things like your hair color that you probably didn't need anyway. And again, how do you represent those? Those are just claims. Again, name-value pairs, where there's a name claim here, there's a family name. Email, in this case, we're saying that Jane Doe's email has been verified, so you don't have to do that dance where you lose 14% of the people. And maybe there's a profile picture for Jane as well, so you can show that and use it in your face. So that's the sort of little bit of a look under the covers of how it works. This is the way the specs are structured. You'll see this little URL here, openid.net/connect. And this is a diagram that you'll find there. When you go to that site, each of these little boxes is actually a clickable link to the real specs, so that you can go there and read them if you're interested in what they look like. They're all pretty short by design, and they're all designed to be pretty quick. One of the ways we made things simple is by building specs in a modular fashion, so that you only need to build the parts that you actually need. You don't have to build the whole thing in order to claim that you're a Connect implementation. So let me peel the layers apart a little bit. At the core is this basic client profile, which is a single document that's intended to be enough for a good developer, or even just a competent developer, to read it and build a working relying party. So that's pretty straightforward. Now, if you need this relying party to be able to use an open set of identity providers as opposed to a pre-configured closed set, after all, this is the OpenID Foundation, so we want to build open protocols. Well, at that point, you need to be able to discover potentially endpoints for identity providers that the person chose rather than the ones that the site chose. Similarly, for an OAuth reason, you have to be able to register your relying party dynamically with the provider. Now, BASIC actually is just a subset of what's in the standard set of messages and the standard binding. So if you're building an identity provider, well, that's a little more work. So you'll read a little bit more, and you'll read these specs. Similarly, if you're interested in managing multiple sessions at once, or you're interested in more advanced features like logout, you'll use this session management spec as well. So it's mix and match, but intentionally in a way that you can use a subset, you don't break anybody else, but if you implement more, you get more functionality. So the stuff here above the line are the OpenID Connect specs. The stuff below are the industry pieces that we're reusing. So there's a set of specs for OAuth 2 that we're using. Again, all of those are pretty well received in the industry and fairly mature. And there's a set of JSON-based cryptography specs, which we just had a working group meeting at the ITF yesterday about, where I've already shown you this JSON web token here at the left a little bit. There's a way to sign stuff, there's a way to encrypt stuff, there's a set of standard algorithms to use, there's a representation of public keys in JSON, and there's a spec for doing discovery. Again, all of those are short and they're reusable pieces. The pieces below the line all actually happen to be happening at the Internet Engineering Task Force, the IETF, and there's at least 4 of us that came up from Paris this morning to be here with you because coincidentally they're meeting down in Paris this week. So how did we get here? Matt and some of his colleagues started this thing called an artifact binding working group back in March, originally to do a kind of binding for the old OpenID 2.0 specs. As they started to look at that and the requirements for it, we eventually realized actually building on OAuth would be better infrastructure. That decision was made in 2010. We began having weekly spec calls to make sure we were making good progress. We closed on the set of open issues of what is Connect going to be in May, less than a year ago, at the Internet Identity Workshop. The board at that point said, oh, we have something. We better give it a reasonable name. And they called it OpenID Connect. I won't even try to say what it used to be called. It was a name that only engineers could love, even though they didn't. We've received a lot of developer feedback since then, which is really important. People build code. They tell you what was clear in the specs, what wasn't clear in the specs. And sometimes they tell you what didn't work for them in their use case. And so one of the most important things in the current phase is finding those things out and gently refining the specs to make sure that they're going to work across a range of use cases, business uses that we anticipate that it's going to be used for. We reached functionally complete in July and began formal issue tracking. We did a round of interop testing in the fall over last year. We simplified the specs based on developer feedback. We published a set of proposed implementers drafts in December, and many of you that are members of the foundation voted to approve those overwhelmingly by 90% vote, 98% vote, which closed in February. So those drafts are now fixed, stable, and have intellectual property protection. And interop testing is ongoing. What have developers told us? Well, the first result is that basic spec that I pointed to. It used to be we didn't have that. We just had the suite, but we expected people to pick and choose and figure out what pieces they need. And people told us, web developers don't want to read specs. They just want one thing, they do it, and then they're done. So we did that. We changed the schema to be shorter and simpler. We changed summary identifiers from being really short to a little more meaningful so that developers had an easier time reading the code. And one of the simplifications was having the ability to get just this ID token, which allows you to log in, but it's optional whether you can get any of the claims. If you don't need claims, if you just need an identifier from one time to the next, you can do that without having to ever get it. So we're not done. And to be honest, I should also tell you what's not done. There's a session management spec, but there's broad consensus in the working group that it's not the right one. Some of the engineers from Google and other places have better ideas of how that's going to work, and that's being prototyped. We're dependent upon that getting written down to be able to finish that aspect of the specifications. Among other things, we want to make certain by really building some implementations that it works well with the account chooser work that you'll be hearing about shortly. There are several remaining outstanding feature proposals that have resulted from feedback on the implemented draft. Most have already been either accepted and incorporated into the drafts, or we've pushed back and said, no, it's not necessary for most users. But we will need interop testing on the small number of new features that have gone in. What are the risks to completing this soon? Actually, it's kind of funny that this is happening this week, because of a lot of the risks are what's going on in Paris right now. Although I'm happy to report that the IETF seems to be on track to be finishing the OAuth specs really soon. The Jose specs, which is JSON object signing and encryption specs, based on the working group meeting yesterday, also look stable. And in fact, that working group plans to take them to working group last call in June. In standards time, June is pretty soon, so that's actually a good result. There's a few specs, the JSON Web Token built on these, and Discovery, that it's not yet clear whether the IETF is going to standardize them or whether we might take a different path. I think these are manageable risks, but just full disclosure, I'm telling you that as a standards process, these are risks that we do have. So what's next? We keep listening to developers, because ultimately they have to build it and they have to tell us, is this working? We need to create the new session management spec. We need to encourage and monitor deployments and keep gathering data from those. And then once all the specs are deemed to be complete and well enough tested that we completely believe in them, we'll hold another membership vote declaring these to be final specifications, at which point we stamp it as done. Now, per what's going to go on for the rest of the day, this doesn't mean that our endeavors as an identity community are done. By no means. There's great business cases to fulfill, the trust frameworks, and actual schemas for real applications. So we're building plumbing. The plumbing is there to help you solve your business problems. So I'll close and take questions with this set of resources on the board. And we'll have these slides posted as well so that you can get to them. If you don't write anything else down, the openid.net/connect page actually has links to pretty much everything else except our personal blogs. What tends to show up on the blogs are things like, I'll post if I've released new specs. Nat's been very good about posting very simple developer-oriented explanations, like I recommend a post called OpenID Connect in a nutshell, which is only 2 or 3 pages, and that's sort of the least technical description of what it takes to build a relying party that is nonetheless complete and actionable. John tends to point out why things are the way they are and answer crypto questions in the way. So with that, can I take any questions? Yes?
Maybe on this one, but could you position UMA in the context of this one?
Sure, let me start, and there's others who actually are working on UMA in the room. I know that the UMA is the user-managed access work where they really want to do this in the Intara initiative. And I know that UMA is using some of the Connect features to do authentication. Now, everything in UMA can't be done just with Connect. And so once again, I think they're taking a layered approach, that they're trying to reuse many of the same building blocks that we've used and that we have in fact introduced. I don't know if John or anybody else wants to follow up on that. Or could you say your name and maybe we can talk about it?
David Alexander, Mike.
Okay, thank you, David. Yes.
Is there any way that we can go and see what the situation is in terms of monitoring that you were talking about? You were trying to encourage deployments and so on. Is there anywhere that that is?
Yes. One place, and I'll just show you on the screen, oops, is there's the interop testing site. There's an organization called Identity Commons that has hosted interops for a number of pieces of identity work. And you'll see up at the top of the OSIS page this link to the third OpenID Connect interop, which is the one that we're currently on. And if you look at results, for instance, there's a subset of the results which are cross-solution results. So you can see the 8 participants. So for instance, Oreo is eBay's implementation. There's a Google demo implementation. There's a gentleman, Roland Hedberg from Sweden, who's written a very extensive set of test suites. There's a number of individuals as well. I know that there's other implementations that haven't publicly put their sites up where people can test. But this is ongoing in one place that you can go to see that progress. Well, Don is hovering, so it must be time for me to go.
Thank you, Mike.
Thank you very much, Don.
And I wanted to thank Ash for coming out and telling me to turn my microphone off. I was just about to hit the men's room, so not only would it have been embarrassing here, but it would have been memorialized on a Google Hangout the rest of the time. Bill, you're ready to roll next?
Yes.
Good. It's always helpful to see the intersection of the kinds of input that Mike put up on that first screen that really goes to the fundamental value proposition, the OpenID Foundation, and I think the power of the protocol itself. So I'll let you take it from here, Phil.
Thank you, Don. So this session, the purpose of this session is to announce cloud identity and privacy services. This is new capability from Microsoft. And with me is Tony Madeline from the product group, who's visiting today, having been in Paris this week for another meeting. So, and just to explain my background, I've just come back to the UK, having spent 5 years in the US, where I was involved in some of this work, so I can talk about some of the sort of initial projects and proof of concepts we got involved with. And then I've come back and I'm now part of Microsoft's consulting team. They've set up a new practice to do enterprise strategy work. And so here I am talking back on products again. So what we want to do with this session in terms of objectives is to get across the capabilities of the new cloud identity and privacy services, to illustrate how they provide significant business benefits in addressing the privacy issues that we face as governments and industry want to try and get more services online, and to take on board the lessons learned from previous Federation technology efforts. So Microsoft has had ADFS out in the market and Windows Identity Foundation out in the market. And what we've learned is it's still quite complicated to get applications, relying parties and Federation up and running. So this service is taking a different tack and trying to simplify that in the extreme. And so we're hoping we'll get some feedback from you on that. So the privacy problems we're trying to solve are the three labels of untraceability, unlinkability, and minimal disclosure. So we're going to step through how we do that with this series. So in terms of the problem statement that we're trying to solve, it is the traditional federation model of identity providers and reliant parties. And the first part of the problem statement is we really want to enable reliant parties to consume verified claims, not just ordinary claims, where a verified claim is the attribute about an individual or some relationship about them. But we want to show that we can support this idea from trust frameworks of having a degree of assurance in a particular attribute, that it's an assured attribute from an assured entity. As we look at how we approach the consumption of verified claims to a level of assurance, we want to do this taking into account existing federation capabilities and protocols and standards that are out there, and allow on top a new set of capabilities to address the privacy problems. And one illustration of this was some of the work we did in Europe and in the US. So we worked primarily with the US local and national governments, with the UK government, and also in Germany. So one of the good ones to call out is in Germany, where they went to the extremes of launching a national identity card to German citizens, handed a smart card. The smart card has on it, I think it's 11 attributes, and they can then share those 11 attributes with reliant parties. And what the German government was very keen on is having invested in their identity provider infrastructure and that service for citizens to get strong means of authentication, is they wanted to show that this could be used across both the private sector and government services. So Microsoft, at about the same time that the German smart card scheme was being launched, was introducing a cloud service called Healthful. So this is aimed at individuals to manage their wellness goals. You register for the service, you can sign up for applications, you can get your devices, you can share your blood pressure up into this store, you can examine your blood pressure and other health indicators, and if you so wish, you can share that information with the statutory sector, GPs, hospitals, or with friends and family. So there was this service that we had up at two extremes, health information and government identity, and we wanted to show how you could introduce solve the privacy problem of if you're using a national identity card that you can't trace and track where you're using it. And so we introduced this capability with the German government and showed that working as a proof of concept. And this spawned interest from a number of policymakers, from end users themselves, from the civil society folks. So what we're seeing is this landscape changing as people look at enabling claims-based access and federation to really having a harder look at what the requirements around privacy and putting that more into policy. So the narrative we're trying to talk to is the claims-based access story. We are trying to speak to the claims-based access story of being used to control access for personalisation. We want to make it easy for reliant parties to just put simple claims such as your email address, be able to get hold of that email address, and to know that that email address is at a particular level of assurance. As with the federation model, the whole objective is to outsource the pain for the application developers and reliant parties. They want to outsource the identity provisioning, the authentication services. So it shouldn't matter to the application and the reliant party and the developers there which a particular log-on mechanism was used, whether it was a smart card, OTP or a password, by the identity provider. What they're interested in is being able to consume the claims that result from that particular service they gain from the identity provider. So that's our goal, is to stick very much with that narrative of claims-based access, as we've been hearing for some while. and to take on board the lessons learned. Now, we mentioned some of the products and experience in putting these things in the marketplace. The other thing we picked up from communities such as OpenID, and this was a colleague who mentioned the experience a couple of years ago, when we tried to talk at a previous OpenID workshop around security and crypto. And there's a significant pushback about about introducing too much complexity into that community, making it too hard to get up and running with the federation model. So we've got Alison. We are working on the basis of, to use this service, you only need to know two commands from the RESTful approach of get and post, and that the claims will be returned as a JSON string. So if you're an application developer that's mastered Python, PHP, ASP.NET, or ordinary JavaScript, then you can use these basic RESTful commands, get and post, to get a set of claims from your identity provider with those privacy properties. If you look at the typical federation protocols, such as SAML and also PKI, then what we see are the issues, the privacy issues, where by default with SAML, the relying party, the two-party SAML model, the relying party will redirect the user to the identity provider. And the identity provider will know where it's got to redirect the SAML token back to. So the URL of the relying party is shared by design with the identity provider. So the identity provider has knowledge of which websites you are accessing your web behavior. One aspect of PKI is its tracking as a side effect of its technology. So with digital certificates, you have the serial number of the certificate as well as the public key, and those are shared with every relying party that you visit. Therefore, it's quite easy to collude and build up a profile of someone's behaviour as they traverse across different properties and websites on the internet. And indeed, with many PKI services using OCSP, there's that call home function of please can you validate this particular user, here's the identity of the user. So our approach is to build on top of that existing body of work, but to build in this don't track by default capability. So let's just take the standard or typical federation model and just explore a couple of other potential security threats and privacy issues. So a relying party application will set up trust initially with a relying party SDS. The relying party SDS will set up trust with an identity provider SDS. And then when the user tries to access that application, the user is redirected to the relying party SDS, then over to the identity provider and authenticates, and claims flow back, as you might just have seen as the animated that diagram. When the user authenticates the identity provider using, say, a strong credential such as a smart card certificate, it's only at that point is a proof key used. In all the subsequent stages of the claims passing through the IDP SDS and the relying party SDS, there is no further use of a proof key, the typical model. So this means both federation services on the relying party and IDP side are open to an insider attack. And anybody who manages to own one of those SDSs and then impersonate that user or harvest information, they will have knowledge of the claims. And one of the things we've seen engaging projects around Europe is this idea of within a relying party domain, an administrative domain in a sense, the application, there can be a number of applications, and they're using a single RPSDS. And an RPSDS can handle all the trust for all the applications within that domain. So the domain could be a department, it could be a particular sector, or in Europe we've seen it even being used at the national state level. So the potential security threats there should not be underestimated with the standard model. So current Federation protocols help with the outsourcing, help of authentication, they help with the provision of claims. So our job with Cloud Identity Privacy Services, CIPS, is to build on top of that. And the technology we're using to do that is UProve technology. And the UProve technology is a cryptographic system, a number of cryptographic techniques that will let you do a number of things relevant. And for this particular exercise, we've applied the UProve technology to the exchange of claims and attributes of identity information for parties for multilateral security. It can be used in the standard ways that you might use PKI to produce digital signatures. It can be used to sign contracts and other documents. UProve can be used for electronic cash and in ticketing applications. But for us, the story is around claims and protecting the sharing of claims. So UProve technology was acquired a number of years ago from Stefan Brands, and Stefan Brands helped to build up the profile of how we share claims using the protocols that are there. And UProve technology was recently moved to the Extreme Computing Group in Microsoft, and the Extreme Computing Group provides quarterly release of the crypto stack. So UProve has been integrated into the Microsoft crypto stack, and then that release is made available to a whole host of different product groups around Microsoft. So it's out in broad terms within Microsoft for use by the product groups. So crypto is different. It's different to PKI. So let's try and call out what are some of the key differences. And there are three main key differences. As I was alluding to with SAML and PKI, you can't escape from sharing correlation handles. With SAML, you're sharing the URL of where you're going. With PKI and the digital certificate, you're sharing the public key and serial number. You can't escape from doing that. With UProve, it's different. There are no inescapable correlation handles. So once you've got a UProve token and you share that with a relying party, the identity provider has no knowledge of where you're going. So the big difference there is the inescapable correlation. There are no inescapable correlation handles. It's quite different to PKI and to typical SAML. The second big difference is we apply a digital signature, but it's different to the signature you get with standard PKI. So with standard PKI, you can't tinker around with the contents. If you go back to that German story of 11 attributes, which will be surfaced in a digital certificate, you can't remove any of those attributes. That's normal to protect the integrity of a PKI digital signature. With UProve, the situation was you can take the 11 attributes that are initially issued in the UProve token, and then you can take some of those attributes out and only release or present the attributes that are actually needed by the relying party. So this is the concept of minimal disclosure. And that capability is in the current UProve technology services of CIPS. And there are future crypto technologies that the Extreme Computing Group are working on, and that we hope to surface in later releases, such as a derived claim, this idea of can I prove I'm actually over a particular age, rather than releasing the actual date of birth. And one of the things that's very common in the use of Federation for, say, accessing a secure service like a government service, is you need to find the identity from the identity provider, such as Post Office, with the identity being used by a relying party, such as the DWP. And in AUFS, we have the capability for a paper ID store, where you generate a pseudo-random ID for each relying party. But with UProve, this is a new capability is coming along where you can create a system but non-trackable, unique identifier. So the identity provider might know that you've proven your identity to a particular level of assurance, and it's got the social security number, but then lets you use a unique identifier based on that social security number in a way that can't be tracked across different parties. So the third and final significant benefit with Uproof is what we call long-lived tokens. So in normal use, as per the demo that we'll have a look at in a moment, Uproof tokens, like SAML tokens, are issued on demand. So if you go to a Reliant party and you redirect it to an identity provider, with SAML you get that token on demand, and with the current release, we provide Uproof tokens on demand. But you can have this capability of issuing a number of Uproof tokens and storing those on a smart card or on your local device to spend as you so wish at different points in time. So this has benefits around privacy and availability to get to your services when perhaps you can't call home to the identity provider. And one of the key scenarios when we shared this idea in the US was the first responder scenario. So if you've got professionals working in health, hospitals, fire, or and they're qualified first responders and will be called out to an emergency situation when that happens, then what they can have on their phone or on their smart card is a cache set of Uproof tokens, which can be issued or refreshed every month. They have a lifetime of a month. And then if an emergency happens, all the first responder needs to know is take the phone or smart card with him. When he arrives on the scene, and this is how it works in the US, you've got a challenge, but you don't get into an emergency area unless you can prove who you are and that you've got a right to be there. And then what they can do is surface the right set of claims from the Uproof token to the point where they're challenged in order to get access. And this has been called out, particularly in the US, because with Katrina, they had horrible stories of teams of doctors descending on New Orleans and couldn't get to help because they were turned away by a simple guy acting as a guard with a gun saying, if you can't prove you've got a need to know, you're not getting in. So there's a big push in that sort of area as to how to exploit the long-lived tokens capability. And going back to the idea of proof keys, one of the great things you can do with Uproof is it's a two-step process. So when an issuer creates a Uproof token, the second step is to then create presentation proof. The Uproof token has a public key, but that public key isn't known by the identity provider, which creates that privacy property of the identity provider doesn't learn who you are. But the proof key can be split across a hardware device. So you can cache some tokens on your personal device. Then in order to do the second step, representing a presentation proof, you can pick half the key from your smart card. So from my Microsoft smart card, I can pick half the key and half the key from the existing token to do that final step of generating the presentation proof. So we did some work with Gemalto as to how they might do that, and they cooked some of the techniques into the smart cards, and they've been showing that at RSA and a few other places. So the takeaways for today is privacy features of Uproof: untraceability, minimal disclosure, and unlinkability. So untraceability is we don't want the identity providers to learn where you go. So they can't correlate the issuance and presentation of claims because it is a two-step process. The minimal disclosure. If the post office can issue 20 claims, you don't want to encourage users to always share those 20 claims. The German government is issuing 11 claims, you don't want to encourage always sharing the 11 claims. Unlinkability. As you traverse across different sites, even within one government department, they may have a number of websites. You don't want marketing people, or for whatever reason, by accident or by design, that collusion happens and they can profile your behaviour. So it's the unlinkability aspect to protect you from relying parties who are legal. So those are some of the benefits. So what is SIPS? SIPS is an Azure service. It's a set of services, let's say composable services, and we'll look at the 5 composable services in a moment. The idea is they're in that cloud, so they can scale, they can be easily accessed by developers, and they can be made invisible to users. So one of the design goals is to make the experience of interacting with the sharing of claims as invisible for a user as possible, and to make it. And the idea of this release is it's not a full-on production release. It's well, we've done some internal projects. Now we want to sort of reach out to you and ask for further projects and proof of concepts to take place, so we can share the value, get some feedback, and move forward. So the architecture of SIPs is two parts sitting in between identity providers and relying parties. SIPs is a cloud service. There are 5 services, and one of them, the user agent, can sit on a user device. So for this demo, we're using an implementation of the user agent on Silverlight, the Silverlight runtime, but it can be implemented on any other technology or other technology. And the idea is, with verified claims, to make it as easy to interact with a Facebook to get an email identifier, as well as with an enterprise or a government department or whoever it is that can provide a great assurance around what it's doing to verify the identity of the individuals and what it's doing to assure the authenticity of the attributes that it's willing to release. So let's look at the 5 component services. The key one to call out is really the start point, the policy service. And to try and get across how we've got a wizard to make it really easy for an application developer to configure the policy for a relying party endpoint. But we've been listening to where the debate is on trust frameworks. So the policy service is in 2 parts. The first part is let's consume the outputs from a trust framework. So a trust framework in government may consist of, let's have 3 trust frameworks at the 3 levels of assurance, 1, 2 and 3. And then they might identify through the trust framework accreditation process that there are 20 identity providers for level 1, the weak one. There are 10 for level 2 and 5 for level 3. And then they might identify what can those identity providers provide in terms of authentic attributes, and they may then draw up a list of attributes. So what we see as the outputs of a trust framework is a set of identity providers and then a set of attributes that can be assured. And so what the wizard does is then elect a relying party, pick the trust framework they want. So it could be the government one or the aerospace one or the health one. That assurance level that they're going to be working to based on their risk analysis of the service that they're actually providing. And then the wizard will say, well, here's the 10 or here's the 5, pick the ones you want from that, and then pick the actual attributes you want from your access control decisions and from your personalization. So it could be 2 identity providers and 5 attributes. That's the policy. We then wrap the policy in base 64 into a base 64 encoded blob, and then we make that accessible to be posted, redirected over to the SIP service. So the policy service is the first point. The protocol gateway will receive the request to authenticate the user, and it will manage throwing up homegrown discovery, asking for selection of identity provider, and then over either OAuth or SAML, it will talk to Facebook or Post Office or whoever it is, get the claims, and authentication will happen as per the rules of the identity provider. Once the claims have been received by the token issuer, the first step of the uProof process can begin. We can issue the uProof credential, so the uProof token. That's the job of the token issuer, and that goes to the user agent. So the user agent can be hosted on a device, a phone, a PC, or it can be put up in the cloud, and that then receives the initial uProof token. And then based on the actual policy requirements, it will do the minimal disclosure, take out the claims that aren't needed, create the presentation proof, and send it up to the relying party. The final step is the validation service. So what we don't want is to encumber a relying party with either an application with unpacking digitally encrypted and digitally signed objects. So you make a simple call out to a validation service with the blob, so you just post the blob up to the validation service, and what you'll get back is a JSON string with just the claim values. And the crucial thing is the SIP service, as it intermediates, itself doesn't learn who the individual is and where they're going. So there's no tracking by the SIP service. Let's have a quick look at how SIPs sits in the standard federation model. And the first thing to call out with identity providers on the left and relying parties on the right is SIPs is replacing the relying party SDS. So what would happen is if you're an agency or a government department, is you would look at SIPs as a multi-tenant cloud service. You'd enroll for it to be a tenant in a cloud service, and then what you can do is configure your trust policy. So you would take the outputs from the trust framework activity as a particular department, and then you would say to SIPs, I trust the post office and Experian and whoever else it is that you've agreed upon by the trust framework. So you set up that trust, so we're bootstrapping the subsequent process. So let's step through the process and how it works. The user points his browser at the relying party as normal. And then the blob of the policy is simply redirected to SIPs. SIPs will fire up the policy in the gateway service to show up the home run discovery screen. You then select from one of the three identity providers as per the policy, and you then redirect it to the identity provider for authentication. Authentication happens and claims are received as per the normal model, and this is over SAML or overall. So between SIPs and the identity provider, we're just leveraging existing SAML OAuth protocols. There is no change on the identity provider. So if your post office and your planning to support SAML as per the recent project-like requirement that were announced, you stand up your infrastructure, you stand up your SAML, you stand up your information, you register and you authenticate users, and you fire off SAML tokens to SIPs as you would do to somebody else. Then magic happens with uproof. The first step is the uproof token is issued by SIPs to the user agent, and the user agent is crucially acting on behalf of the user to submit the presentation proof to the relying party. The relying party then does another simple post to the validation service in SIPs and gets back the JSON string. So that's a walkthrough of how the SIPs architecture builds aligns with the Federation architecture. At this point, we're all going to be brave. I'm going to have a drink by now, what's going to happen? We can ask Tony White first time. Right, here we go. So here's the samples. So there's two samples. Maybe I'll just do one as Eric's chasing me. And we've set up two policies with different sets of identity providers and different attributes that are required. So this would be you landing at some agency that's offering a set of services, and the two pages that I'm going to click on, they're just going to look for context. Is there a security context and a set of claims set up? If there is an existing context, it's going to pop you straight to the application. There isn't, I hope there isn't. It's going to. But what it's done is taken the blob, redirected to SIPs. SIPs has then thrown up the home discovery page. So we do have to pick one of our identity providers. And I appreciate some of the audience are going to be talking about the NASCAR problem. I log into Facebook, prompted by the in-step privacy network. what I should have highlighted in my rush to get the demo going was when you saw the home run discovery page, it actually put up the policy of not only the already identified as choose from that NASCAR screen, actually the top actually said these are the 2 claims I'm asking for. So this is the first. So where we've got, we're trying to also implement a consent model and put a consent model into the policy as to do you always want to prompt for consent to release attributes, or just the first time only? Do you want to have consent done by SIPs, or done by the relying party, or done by the identity provider? So there's different sort of options for the consent model, and trying to encode that into the policy so that the services obey the policy, and that can vary dynamically. So here we can see that the 2 claims that were asked for is who issued that claim. So in this instance, hopefully it's only Facebook. It's first one is Facebook, and then the identifier from Facebook. So that was the simple, wonderful login federation. So let's press on in the interest of time. That was it working. And the key thing here is 4 steps to SIPs. So how do you use SIPs? And I'm trying to get across that setting up the policy, configuring policy, is something you do out of hand of the application. So this is at the domain admin level rather than the application development level. So you set up your policy, and then for the application developer, it's really simple. You just need to redirect the user to the policy URL with the blog that you get from the policy service, and be able to accept the post back of the presentation proof. And then, if need be, you can validate the presentation proof using either the SIP service in the cloud, or what you may want to say is that validation service is too important, I want to park that somewhere safer. So rather than in the public cloud, you could park the validation service in a private cloud, for instance, and that's how we can enable that sort of composition and distribution of services. So those are the 4 key steps, making it really simple. Take the outputs from trust frameworks, set up the policy, and then make it really easy for application developers to get going and get things up and running. So quickly finishing on standardization. Obviously, if we're working on this, we want others to work on it. So about 18 months ago, it went into SC27. It's got the label 29191. And it's actually called requirements for partially anonymous and partially unlinked authentication. So whilst Ucrew has the ability to do anonymous authentication, we're calling it partial because we've got to recognise there are valid needs from law enforcement and legal discovery reasons to be able to say if someone comes along with the right warrant, can they actually find out who somebody was. So we're taking that into account, and that's the direction of the standard is going. So Microsoft has contributed to it, and I'm aware there's input internationally from Japan and France. So it's moving along, and the expected completion is 2013. And in terms of status, so we've got additional work still in the crypto, but there are some good capabilities there today. We have a cloud service up and running. We've done some internal projects with a few parties, and now we want to extend that. And we're looking, in terms of the timeline, what is the roadmap? So there's no formal announcements on the roadmap. It's just an indicative that where we are, we can look for hopefully a more production release in 2013. And resources are here, but you can look up those afterwards. Needy Croce is an interesting character. Who's heard of Needy Croce? So she's a DC commissioner. So we had an experience of $500 million being taken off us a few years back. So it's interesting to see how Needy Croce is now in alignment with the need for stronger privacy and stronger privacy protection technology. It's great to see that we can now talk with a clean and pure heart with these commissioners. Jim.
In a model or in a commercial model where relying parties are paying identity providers twice, how does the identity provider do billing?
Good question, Jim. And I think that's really going to be solved at the trust framework level. So we can build in mechanisms. I think it's got to be down to what is the trust framework going to do to build in those capabilities itself. But I haven't got an answer to that. It's not something we've specifically worked on. We do see that as work happening at the trust fund.
So this does provide ability to have anonymous identity. There is a way that you use it for tracking usage without necessarily tracking the individual. So that's been built into the process as a training procedure. So like counting streams of videos, you may not want to know who's watching the video, but you want to know that there's one active stream.
Any other questions?
The SIPS obviously raises issues around transfer of liability and other legal bits of stuff. Is there any thought or any group focusing on looking at the legal and commercial practical implications?
So we're participating in many sort of initiatives, but they're really industry initiatives. So I mean, there's several.
So we have been in contact. We've been working with CDC to make sure that takes care of certain privacy with respect to the users.
Great. Okay, we're going to turn it over now to Patrick Harding, the CTO of Ping Identity, which is another one of the OpenID Foundation sponsoring members. Patrick, feel free to go a little afternoon. We'll speed up lunch.
All right. Good morning, everybody. Thank you, Eric, Don, for having us here today. Actually, a colleague of mine, Ken Dingle, represents Ping on the OpenID Foundation board. She's not here this week. She generally always comes to these things. We have some other things going on in London, so I'm sort of stepping in, so to speak, at something that she would actually probably normally speak at. So, one of the things I was asked to talk about today was to really sort of step back away from sort of deep diving on OpenID Connect sort of protocol and sort of look at it a little bit more from, say, an enterprise standpoint at sort of why or where enterprises, given everything that's been going on around identity for the last 10 years and all the stuff people have already done, all the protocols we already have, and now we've got OpenID Connect coming along as well. How does this all fit together? What's all this stuff that's happening? Where's this stuff going? We sort of, there's a gap we've got to cross, or bridge we've got to cross, basically get to through OpenID Connect world, which I think will actually happen 5 years down the road. But there's a lot of other stuff that's already been going on. So I'm sort of going to cover some of that stuff and sort of, hopefully make everybody a little bit more aware of what the other things are, how they relate, how they interrelate, how they can be used together, how can they be well together, and things like that. So, briefly, why use standards effectively? Really the point here is that the two parties, the two entities, shouldn't have to understand their infrastructure for what's on either side. They should be able to leverage this sort of standard protocol both can speak to, it interoperates, and information can be exchanged effectively between the two. There shouldn't have to be any prior knowledge of the fact that one party is leveraging Microsoft infrastructure and some other party is leveraging sort of Google infrastructure, things like that. The sort of trick is, though, that just to make some of these things work, quite often you've got to sort of make changes in your delivery mechanisms as you basically achieve the end goal, possibly a single sign-on between different applications. So I talk about different sort of scales here on sort of train tracks, but you can think of an example here that when you start in a Windows application with the Kerberos token, and you need to end up in a SaaS application that basically is going to set a session cookie in your browser. To move from one to the other, you'll likely go across and move across a whole bunch of different token formats or even some different protocols to get there. From a user experience standpoint, it just all happily works. But under the covers, quite often lots of complex things are actually going on. So when you think about what are some of these protocols you sort of care about, we tend to break into sort of three high levels. One is sort of internet scale, cloud scale, where we sort of tend to think we can see the standards today that we talk about. It starts with SAML, with an OpenID connect today, that's all relevant and real. But if you sort of narrow that focus or that scope down more to within the enterprise effectively, you've still got lots of stuff that's been put in place over the last 10, 15, 20 years. They're sort of doing similar things, just in a localized format within that domain. Whether it was the Kerberos environment or WAN products, sort of web access management products that you get from CA or Oracle or from IBM, or it could be the sort of application server frameworks, things like that, basically. And then you narrow it down again onto a specific application, and you have some of the same problems here about just how do you get information in and out of these apps themselves when application servers that people write to have security contexts that the developer has to work with, and that application server tends to set sort of session cookies and things like that within the app server. All of this has to basically fit together just to be able to move a browser from one application inside the enterprise out to the cloud and stuff like that. We actually tend to find that most of the work in getting this stuff done inside companies actually starts, most of the work is in that what we call that first mile, last mile integration, actually getting the app enabled to use the local federation server, the local federation service, and then basically let everything flow from there. It's getting those apps integrated with what are basically legacy protocols now. So, as you think about taking advantage of these technologies, we suggest that you know and understand these scales that we're talking about. Obviously means you've got to know and understand your infrastructure and your architecture. Also important, some of these protocols and technologies are front channel focused, where things pass through the browser. Some of them are back channel focused, where things pass directly between applications. Those all impact how things basically are done, how things work. OpenID Connect supports both models. You can have a front channel only model if you just want to simply pass a user's identity or identifier. But then it also steps into a back channel model, because if you need to get additional attributes or claims, you've got to start making back channel calls. And so understanding when you need those sort of things is important, because it actually impacts the architecture. So, as I sort of mentioned, there are different ways you can change the delivery mechanisms, you can change the containers being tokens, the delivery mechanisms being the protocols that carry those tokens around, whether it's SAML or OAuth or OpenID Connect, or you can be doing both effectively. We have examples of both too. So, 5 years ago, I would have been standing here talking about things like SAML and SPML and the XAML as sort of identity standards. I come 4 to 5 years, and now we're starting to talk about standards like OpenID Connect and OAuth and SCIM, something else I'm going to touch on as well. Effectively, why has this changed? What's changed essentially? There's a lot of these sort of protocols, as Mike mentioned when he talked about a JSON web token. It's semantically identical to a SAML token. So why am I even standing here talking about this? Why have we reinvented it? Basically, those two things. 5 years ago, iPads and sort of iPhones and app stores and native apps on phones and cloud services were nowhere near as prominent as they are today. And essentially, that amount of new infrastructure and the underlying sort of direction that developers have taken has completely changed the game for us, effectively. So there's been basically 3 directions that that have sort of come along to impact the world of identity effectively, and why we need things now like OpenID Connect and OAuth. One is sort of REST as a programming model. I sort of basically don't think that REST is, we see certain REST as peers. We certainly see SOAP happening in the enterprise a lot. REST is basically the thing that sits on the edge of the enterprise, interact with mobile devices and cloud services. There's quite a lot of translation between the two. It still happens. What REST lacked was a security protocol. Where in the SOAP world, we had to sort of build up all the WS security, WS trust, that sort of stuff. But, it was implemented inside companies. It came with its complexity, as we know. REST, sort of top-down, very lightweight, very simple, easy to code to, but developers ran away from security. And basically said, all right, we've got SSL, we've got HTTP basic, we're done, we're good. Well, that sort of didn't cut it, which is where OAuth 2 now has come along to be the sort of authentication authorization protocol for REST interfaces. And that's sort of foundational, that's a big, big, big deal. We think that OAuth 2 is going to end up being sort of a substrate for so many other things that are running on top, effectively, because it's flexible enough to solve lots and lots of interesting problems, as I'll talk about with OpenID Connect is built on top of OAuth. Uma, that somebody mentioned previously, is built on top of OAuth, basically using Next Access. So there's just lots of great things there. It's also very simple. It's about getting a token and using a token. That's it. I'm not talking about those security tokens, which sort of now, everybody sort of in the community, if you understand what I'm talking about. When we say tokens, we mean basically a block of data that contains claims and attributes about someone at the sign. And that could be a SAML token, a JSON web token, a Kerberos signature token, things like that. But basically, OAuth has been optimized for this new world to support REST, to support JSON, things like that. So we got a lot of questions about, there's a lot of investment in SAML over the last 10 years. So people have always asked us, well, how does OAuth relate to SAML? Does it replace SAML? Things like that. And what we've found is that they're actually extremely complementary. They actually work very, very well together to solve certain problems, certain use cases. The first example I have up there is where SAML can be used to basically carry the OAuth access token, effectively, as an alternative to, that would be very similar to the way the OpenID Connect protocol carries the OAuth access token today in certain situations. So we've seen certain environments that have, Intuit is a good example, where they've wanted the security that SAML can provide for federation, but needed to be able to move access tokens around to their partners, so their partners could make API calls back to Intuit to get data. So they've basically chosen to pass those OAuth access tokens inside SAML messages. The reverse is true too. We see some people looking at passing SAML tokens around inside OAuth messages as a federation model between OAuth ASs and RSs as well. Another one that's interesting is where they're sequenced together too. This is where this is appearing in situations where certain cloud applications are making available native clients to their customers that are installed on the phones. So I might have the Salesforce Chatter app on my phone, or the Box.net app on my phone, or the Cisco WebEx app on my phone. It's installable apps. But I don't have a password for any of those applications because my company said, no, we're going to make single sign-on happen. You're never going to have a Salesforce password or a Box password. Well, how's that single sign-on going to work when I have now native app on my phone? So what these companies are doing are basically leveraging OAuth in these native apps to basically make the API calls to get back to their service from the phone. Those API calls have OAuth access tokens. But to get that OAuth access token at the point of me logging into that native app, they're basically leveraging a mechanism where the app is basically passing something across to their local SAML aligned party at Salesforce and kicking into a federation flow with SAML. So the user experience, I'd love to have demoed it, I just didn't have the opportunity, was that if I start up this native app on the phone and click login, basically the next thing that happens is the login page of my enterprise appears that I would normally see when I'm basically logging into the web app and stuff like that. I enter my Active Directory credentials and then I'm in. So the user experience is totally seamless, but they've sequenced together OAuth and SAML at the same time to do it. So second major thing that's going on is directions that we're starting to see APIs themselves becoming standardized. The nice thing about REST was, hey, it's REST, I can write whatever API I want, it doesn't matter effectively I'll get publish it, people come find it, stuff like that. But we're starting to see standardization of APIs. So basically, this is going to be necessary, especially in the identity space, for this stuff to scale. You can't have, a good example here is around how users get provisioned into applications. It's a classic identity management problem, but we've failed to solve it very well over the last 20 years because just even recently people have implemented their own REST APIs. Google's is different from Salesforce's, is different from Microsoft's, is different from Cisco's, and they're all effectively doing the same thing. It's all create, read, update, delete for a user account with certain attributes to put them in there. But everybody's done it sort of slightly different. It makes no sense. There's other examples of that as well. So standardizing those APIs is important. So one example of that, as I touched on, is SCIM, Simple Cloud Identity Management. It basically defines the REST interface, the REST API, for managing those user accounts. So I can create a user, read a user, update a user, delete a user in different applications. It's a REST API. It has a schema in it. In relation to sort of OAuth, it's REST API. Hence, it can be protected with OAuth. You use OAuth to authenticate to it, whether that's sort of generally more of a two-legged model. So again, OAuth and SCIM working happily together. We've found that the SCIM attributes can be included in SAML tokens as well, so that they can be passed around for just-in-time provisioning. The work's going to be done where that SCIM REST API will be used with OpenID Connect, so that effectively the two of them will work happily together as well. And in that regard, think of the SCIM endpoint as being synonymous with the user info endpoint that's in the OpenID Connect text today. That user info endpoint, sort of more of a consumer-focused view of what the user is, SCIM providing more of an enterprise-focused view. So I'm not going to cover this in huge detail. One of the things about OpenID Connect that's really exciting for us is that really we don't want all of these protocols, multiple protocols to be existing, say around SSO. I don't want to have to be doing all this translation in 15 years' time. We don't want to have to bridge from Kerberos to SAML and stuff like that. OpenID Connect, we're hoping, and we're sort of telling people this, that we think after years of learning, that we might have got to a point where we have something flexible enough to address both the low assurance use cases and the higher assurance use cases in such a way that we can have one protocol that can solve all these problems. So I remember 5 years ago, we would distinguish between SAML and OpenID as one addresses low assurance, one addresses high assurance. Depending on what the use case is, pick one over the other. OpenID Connect is going to allow us to get to a point where we have one protocol. Imagine if today we're still talking about the fact that I use SNA inside my organization, I use TCP out on the internet, and I bridge between the two, and it would be insane, right? So OpenID Connect is going to allow us to get there, the fact that we can actually start to use one protocol for this use case. So we're really excited about it. It also comes along and addresses some of the things that were missing, say, from SAML that were addressed. So you might say they're going to basically rework it because they don't like how they're doing it. But that's fine. Session management, which speaks to session synchronization, which speaks to how you handle logout. Everybody comes on that today. It's basically ignored. But I think there's enough people who really want to, irrespective of what Eric wants to say about it, you guys completely ignore it. So we're excited about that. So then, lastly, sort of two other things. Scaling this stuff up so that effectively we can break away from this peer-to-peer relationships. The gentleman from Microsoft was talking about before. You tend to have bilateral relationships today where information is exchanged to set up a federation flow between two companies. That's going to have to change. This is really going to scale out to thousands of cloud applications and thousands of organizations and things like that. There's things we're missing to really make that happen. It's really, I think of it as creating a trusted mesh. still going to be a mesh where things are exchanged between, bilaterally between all sorts of organizations, but establishing the trust underneath that so that each party doesn't have to negotiate together. Another example, imagine today if to set up networking with all of the companies I want to do business with, I have to basically talk to every one of those guys directly to set up the lease lines that we used to do. Now I just connect out to my ISP on the net, and he worries about routing it out there effectively, and those packets just get there transparently. I don't worry about it anymore. It's those sort of models we have to start to apply to identity to allow this stuff to truly scale. And there's some work going on there around that. The trust framework work that's happening in the US, and I think there's some equivalent stuff happening here in Europe as well. That's exciting. I mean, that whole establishing trusted metadata and how that can be exchanged and how it can be effectively audited and things like that, so people can leverage it, is going to be great. There are other models as well, broken models, where you have a third party, sort of trusted third party in the middle, that mediates things. I think they're going to work for a period of time. I don't think they're going to essentially work long term at internet scale, just because having those trusted third parties, they end up being men in the middle, which along comes the risk of SLAs and support, and what happens if they go down, and that person can see everything. I just want to get rid of my partners, but I want to simplify how I do it. So sort of in that model of making internet scale is sort of what we traditionally call the IP discovery problem. Eric's going to talk a lot more about the account chooser. We've gone through multiple iterations of trying to solve this problem. In the OpenID world, they've tried to solve it with starting with saying, just give me your URL, and then we've had the NASCAR page, and account chooser, I think, is an opportunity to sort of address that. In the enterprise world, basically, people have not even sort of done the SSP-initiated SSO model because it was too hard. They've always focused on IDP-initiated. SaaS applications have had to change their URL infrastructure, the URL architecture, so that the name of the company using the service is bound with the URL, like kingidentity.webex.com is the URL I go to there. It's all broken. It's all over the place. To really make this internet scale and to really deliver on a notion that apps aren't going to need passwords, we're going to have to completely retrain users to step away and think about login forms and the traditional ID password and shift to a completely different user ceremony, which is where the account chooser is really exciting. What's nice about account chooser is it starts to address again the combination of the consumer use cases of federation and the enterprise use cases of federation in one step. And again, so that everybody can start to consistently see a new login ceremony, irrespective of what they're doing. So with that, I'd like to thank you. Any questions? I'll take questions. I know I'm sitting in between people on lunch and stuff like that, so good to go.
Thank you, Harry. We have a lot of material to cover, as you can already see, so I would ask you to come back a bit early for lunch so that we can sort out.
So this thing is still on as I get on the cab.
That's right.
Okay.
That's right. We'll be following you all the way to Heathrow.
There you go.
So let's take a break now, and if you could be back at 1 sharp, that'd be terrific. Thank you very much.
Hey, Don, do you want to tell us, point people to where it is, or is it just outside? It's just okay. Those of you on the video, we're going to drop off for about an hour, and then we're going to start it back up again. Thank you.